Hello and welcome to another session in mathematics. In this session, we'll be looking at the topic differentiation. But before that, let us take a review of our previous lesson. Welcome back. Our main focus today will be on differentiation from the first principle. Differentiation from what? First principle. So let us start with the definition of the term differentiation. Okay, differentiation deals with the rate of change written as this. Okay, rate of change of one quantity relative to another at some particular point. Let's say x, and then if x have an increment, there will be a change or a shift from the level where x is, either to be x plus 1 or x minus 1. Is that correct? To be x plus 1 or x minus 1. So the change may either be positive or what? Negative. For the positive, we call it what? Increment. For the negative, we call it what? Deduction or decrease. Is that true? Now, these two changes of the variable s is denoted by dx. Okay? Or you can just call it dx. Okay, this is called what? Change in x. Change in x. So if x increases or decreases, we denote it by this. Okay, so we'll be looking at what? The rate of change of what? Variables. If it is y and there is change in y, we'll call it what? dy. Okay, so differentiation deals specifically with what? Changes in the rate of what? So differentiation specifically deals with what? The rate of what? Change of one quantity relative to another at some point. Okay, let's quickly take the differentiation from the first principle. If we are given y to be equal to 2x squared, if we are given y to be equal to 2x squared, there are steps we follow in solving differentiation from the first principle. Step one is to take the change in both sides of the equation. The change, and I told us that the change in y is what? Is written as what? dy. Change in x is written as what? dx. So when you take the change in the both sides, then you add it to the both sides. So if you have y plus what? The change in y to be equal to 2 into x plus what? Change in x. Because of this power here, you still add your what? Your power. That's step one. You take the change of what? The variables. Now if we open this bracket, our y plus dy, follow me and you understand what I'm doing. Our y plus dy will be equal to x plus dx into x plus dx. You know why we did that? Because we have what? A power here. And our y plus dy will be equal to 2 into x times x is x squared. X times dx will give us x dx. We'll come to this. Dx times x will give us x dx, not dx squared. You know that, right? Then dx times dx will give us dx squared. We collect like terms. Our y plus dy will then be equal to 2 into x squared plus this is x dx and x dx, so we have 2x dx plus what? Dx squared. Opening this bracket, we have y plus dy to be equal to 2 times x squared will give us 2x squared. 2 times 2x dx will give us 4x dx, and 2 times dx squared will give us 2 dx squared. As step 1 is satisfied, then we'll go over to step 2. Step 2, we subtract y from both sides of the equation. Subtract what? Y from both sides of what? The equation. Therefore we have y plus dy minus y to be equal to 2x squared plus 4x dx plus 2 dx squared minus what? Y. Okay, we have y plus dy minus y to be equal to, remember this y here is given to be what? 2x squared, so we replace it here. We have 2x squared plus 4x dx plus 2 dx squared minus the value of y, which is 2x squared. Okay, now this will cancel this and this will cancel this. We then have our dy to be equal to 4x dx plus 2 dx squared. Okay, then we go to step 3. Step 3. In step 3, we divide through by dx. We divide through using dx, so we have dy over dx to be equal to 4x dx over dx plus 2 dx squared over dx. Okay, this will eliminate this. Let's go to the next slide. We then have dy over dx to be equal to, we have 4x left here, 4x plus dx squared is dx times dx, right? And this will eliminate one of the dx, leaving us with what? 1 dx. So we'll have 2 dx. Then we'll go over to step 4. Step 4, dx tends to 0 in the right hand side of the equation. Okay, so wherever we see dx, we replace it with what? 0. Therefore we have dy over dx to be equal to 4x plus 2 into 0. Our dy over dx is equal to 4x, and that's our answer. But there's a good news. There's a shorter way of solving this. Very, very simple. Okay, if we are given y to be equal to x raised to power n, then dy over dx is equal to nx raised to power n minus 1, and this is the formula we'll be using in solving that. Okay, if we're given y to be equal to 2x squared, the example we just solved now, all you need to do is to bring down this power, which is your 2, multiply the coefficient, and then write down your x, subtract 1 from the power. You have 2 minus 1. 2 times 2 will give us 4. Then bring down your x. 2 minus 1 will give us 1, just 4x. And that was exactly what we got when we solved using the first principle. Okay, so let's solve some more examples. Assuming we are given 2x squared plus 5x plus 5, our dy over dx is equal to 2 times 2 will give us 4. Write down your x. Okay, what's the power of x here? 1. 1 times 5 will give us 5. We have x raised to power what? 1 minus 1. And the differentiation or the derivative of a constant is equal to 0. So 5 is 0. Okay, we then have dy over dx to be equal to 4x plus anything raised to power 0 is 1. So we have 5x raised to power 0. So 5 times 1 will give us 5, and that's our answer. Okay, if we have y to be equal to 20x raised to power 3, it's just simply 3 times 20, which will give us 60. Bring down your x, then 3 minus 1 will have 60x squared, and that's the answer. Okay, thank you for joining us in today's class. I hope you really enjoyed the class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with differentiation from the first principle, and we've taken some examples. We'll call it a day here. In our next class we'll go over to solving some more examples. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your questions or comment on the comment section. Till we meet again, stay safe and bye.